Midterm number 1, question 6b, summer 2021. Okay, so basically, okay, this problem kind of goes hand in hand with the previous part, okay? Like we gotta find the minimum and we gotta swap it with the node before it, okay? So we can use the previous part, right? We can assume that works correctly. And we can also assume that the minimum is never the first node. Okay, why do we have this assumption? It's because if it was the first node and we had to swap with the previous node, what is the previous node? Is it Sentinel? Is it the last node? You know, it's kind of complicated. So we don't worry about this case. Also, we only have 8 lines to do this, okay? So we got to think about how to use our lines smartly here, or intelligently. Smartly. Okay. So here's the setup. I've drawn everything that we need to know. Okay, so here's the minimum node. I've called it min. Here's a node before that we've got to swap it with called before. I wanted to call it prev, but prev was taken by an attribute of the node class. Okay, this node's called L. It's not because we're taking an L. It's because it's the left of before. Okay, and similarly, R is called R because it's right of min. Okay, this is what we need to do. Okay, now it may not look like it, but every single arrow here has been modified. Okay, all 6 of them. Okay, L.next, it's not before. It is now min. Likewise, before.prev, it's now min. Before.next, it's not min anymore. It's R. Min.prev, it's now L. Min.next, it's now before, and R.prev is now before. Okay, if we want to assign 1 arrow per line, we would need 6 because there are 6 arrows. So we get 2 lines to do other stuff, but that's okay because basically all we need to do to modify the order of like these nodes is precisely just modify the like next and prev relationships, right? Because that's what determines the order. So we have 2 lines to actually basically just assign variables, which is kind of nice. Okay, let's get to the actual code. I've given us 8 lines here. So first thing we want to do is probably just go node min equals get, okay? Because we got to get the minimum nodes. Another thing that might be helpful, because we have another line before we start reassigning the arrows, is we go node before is equal to min.prev. Okay, we've got that one now. Okay, let's go back to our diagram real quick. Okay, so it's maybe a little hard to think about you have to think carefully about the order in which you reassign them, because let's say that, for example, I decide to go ahead and say L dot let's say I want to go ahead and reassign before.prev to be min. Okay, I just lost L. Why? Because L was before.prev, and that actually happens to be the only like access I have to that node. So if I reassign before.prev, okay, we get rid of this arrow for a second. Okay, shoot, we don't actually have a way back there. So we need to be very careful, okay? So, okay, maybe let's reassign min.prev, okay? Because we can actually get rid of all the pointers of before and min because we've got our own local pointers though. Okay, let's go ahead and do that. Let's go ahead and say, let's go ahead and say min.prev is equal to before.prev. And likewise, we can actually go ahead and get a pointer to R right now, right? Let's use a similar logic. We can go say before.next is equal to min.next. Bob's your uncle, you've got R and L together. And now we can kind of maybe go left to right, okay? So going back to the diagram, okay, like, so what did we do? We signed, okay, we have L, we have min pointing that way and before pointing that way. Okay, so maybe let's just go left to right. Let's assign L.next to be min. So let's do that. So min.prev is equal to min. Okay. And left to right, okay. Let's go back and take a look at this. Okay, let's fix these up. Okay, so min.next needs to be before and before.prev needs to be min. Okay, so min.next is equal to before and before.prev is equal to min. Okay, we've got 1 line left. Oh man, this is really pushing it, isn't it? Okay, so we've got all that correct. And we know that before.next is R. So all we need to do now is set R.prev to be before. Okay, so before.next.prev is equal to before. I feel like I made a mistake. Ah, I did. Okay. right, I set min.prev to be min, meaning min points at itself. Sorry, this should be min.prev.next, okay? Because min.prev, okay, that gets us L. If we set that to min, it's going to point back at itself. So we need to set L min.prev.next to be min, okay, to be as we expected, okay. And I think this is our code. So I made that silly little mistake. Let me go back through and make sure that this is all correct, okay? We got the minimum node, we got the before node, then we set the previous, okay, to be before.previous, which makes sense. Okay, we set min.prev to be L, then we set before.next to be R, then we set L.next to be min, then we set min.next to be before, and before.prev to be min, and then we set r.prev to be before. That seems correct to me. So yeah, so this is it. This is the solution to swap min. So I hope that these videos have been helpful. I hope that the other videos you might be watching for the midterm are helpful. Yeah, I don't really have any wise words to say, but yeah, I guess I hope that you have like a better appreciation for linked lists, because these are some really like good fundamental concepts to understand, and they'll be very useful to you. So yeah, so with that said, I hope that all of you maybe had some fun or got some enlightenment out of watching these. I don't really know. I don't know. I hope it was useful and maybe a little entertaining. Okay, bye-bye now.